And saved me with teaching me how to work this OBS better. Okay, so this is surface area. Be careful. Thank you. Be careful because we have different formulas depending on what they're asking for. And if you don't read the directions carefully, you can get these incorrect, right? So the surface area formula for a cylinder, and this would be a cylinder, is 2 pi r squared. It's 2 pi r squared because you have two circles, top and bottom, right? And the area of a circle is pi r squared. If you recall what the netting of this looks like, it's a rectangle. The pi d stands for the length of the rectangle, which is actually the circumference of the circle. And then the width of the rectangle is actually the height, when it all folds up together. So what's the radius of the cylinder? 12. And what's the diameter? 24. And then what is your height? 7. Very good. So this is going to be 2 pi 12 squared plus pi times 24 times 7, because we just substituted. And this would be surface area. So I'll use my handy dandy calculator, and I would do 2, is that a pi? Where's my pi button? There it is. 12 squared, oh, squared, plus pi 24 and 7, right? And then press enter, and it says here to round it to the nearest tenth. So I would say this is 1,432 point, what was it? 0.6, yes. Km, now it's surface area, so what should the exponent be? It should be a 2 because we're talking about area. Okay, so in this case, we have a pentagonal prism, right? Where we have two pentagons as our parallel bases, and around the outside, we have 5 rectangles. Do you see it? There's a beautiful face I haven't seen for a minute. I'm glad you're back. Okay, so pentagons, we have to use that 0.5 times apothem times perimeter, right? What's my apothem? 4.1 is the apothem. To find perimeter, it's the side length, which would be 6, times the number of sides, which is 5, so that is 30. So I have 2 pentagons with the formula 0.5 times 4.1 times 30. And that would equal, okay, thank you. So this, and you put the 2 with it, right? 61.5. No? Okay. It's 2 pentagons, so I would multiply this by 2, right? And now it's 123. Now I'm going to do, let me portion this off so it doesn't get, that's the area of these 2 pentagons, top and bottom. Now I have the 5 rectangles all the way around, right? And so there's 5 of them, and the length of the rectangles are going to be the 6, and the width is going to be this height, which is 12. So it would be 72 times 5, right? How much? 360. And then what do I do with this number and this number? I have to add them together to find a total surface area. So that's 4A3, and that would be feet squared. That would be our surface area. How are we feeling on surface area? Are we feeling any better on these? This next one, we have some. Yes. So this is a cone, and the volume formula for a cone is 1/3 pi r squared h. What's r? 8. What's the height of the cone? 16. So it's pi times 8 squared times 16. And 1/3 just means to divide that by 3. That's easier to put in your calculator. So go ahead and do that for me. One, and it says hundredths. So wow, you're pretty good. You even read the directions. And that'd be km to the third power. So I asked my husband, because he's an engineer, because we have these type of conversations, what place value do you have to round as an engineer? And he goes out to the hundred thousandths, because they have to be more exact. Just FYI. Okay, so capital B means area base, right? Where height is the height between the two bases. This is a prism, and it's a hexagonal prism. It's a hexagon because the parallel bases are hexagons. So I need to just do the area of the base times the height. So capital B is going to be that 0.5 times apothem. What's the apothem? 6.1. To get perimeter of this, you would take 7 times 6 because the length is 7. And how many of these do I have? 6. So what's 7 times 6? 42. So this would be 42, right? Oh, I don't know why I jumped like that. So what is that answer? What's 0.5 times 6.1 times 42? Okay, so that's the area of the base. Now I need to multiply the area of the base times the height for the full volume. What was the height? 5. So it's going to be 128.1 times 5, right? And so what's my volume? And since it's volume, that's when I use the cubic. Tomorrow we're going to have a visitor from Decatur Excel Center. They are they reached out. They got a brand new math teacher, and they wanted somebody to kind of observe my class just to see how I run a class with adults. And they chose me, so we'll just have a teacher in here tomorrow. Just be nice, be nice. Oh, by the way, yeah, tomorrow during lunch, they're going to be reviewing your rights for immigrants. So there's a paper there at lunchtime at noon. You all may want to sit in on that if you are an immigrant or if you are friends with immigrants and want to know all that information. So noon tomorrow in the break room. No, it's not in the break room. It is in Mr. Ani and Miss Ren's classroom. Well, have you been watching the news? It's all about your rights. What you can claim as your rights. Okay? Okay. Let's get back to math. Sorry, but that's very important for some people. Okay, this is an apex, right? Where it all meets up at a point. So this is a pyramid. This base, though, is a triangle. So this is where you will have a small b and a capital B. I must have read your mind yesterday when I made this. Okay, so the capital B is the base, right? And I need to find this area, but it is a triangle. What's the formula for a triangle? Yep, base times height divided by 2. Now, this is a right triangle. See here how it's a right triangle? And when we talked about triangles, if it's an acute triangle, this would be your height and this would be your base. If the height would be in the center. If it was an obtuse triangle, you would draw a height here and it's connected to the base. So this would be height and this would be base, right? On a right triangle, it's your legs that are your height and base. And one, it doesn't matter which one you call height and which one you call base because I can turn it, right? So I'm going to call this height and this base. Does that make sense? Okay, so if I'm looking at this triangle right here, what it's sitting on, what would you call, and here's the right angle right here, what are you going to call your height and base of this triangle? 8 and 6. 10 is the hypotenuse, which is not the height and base. Your height and base is what makes that right angle that it's sitting on. So, to find the area of the base, we're going to do base times height divided by 2, where our base and height are 6 and 8. So 6 times 8 divided by 2 is going to give us what, 24? Okay, now I need to do volume equals 1/3 or divide by 3, whichever way you want to do that, times 24. What's the height of the whole pyramid? That's the height it's talking about up here. 7. So then you multiply this by 7. So if you're putting in the calculator, you may want to do 24 times 7 divided by 3, like that. That's another way to find volume, which would be what? 8 times 6 is 56, so it should be 56 centimeters cubed. Is that what everybody got when they threw it in the calculator? Okay. Well, when you're looking for volume. But let's say you had, let's say this was a triangle, like a wedge, like when you know what I'm talking about? That, like if you had two parallel triangle bases and a height in between, you still would do the same thing because you always have to find the area of the base. Yes. That's when you worry that you have two B's in the formula. Good question. Okay. What do you need? Oh, you want the blue things out? Okay, let me do that. It gets me out of my seat. One, two, one, two. You did not take a Bex and Bernstein bears. That works. Thank you. Okay, so I'm going to pull up a different one, so you may all have to read it to me. Oh, I have it here, but I'm going to make it again. Okay, so it first says what? Draw a circle. And what am I going to name the center? C, right? Now what does it say? What's the second step? Okay, so I'm going to draw a radius, and what do I have to label it as? So and I'm going to label this as AC. Oop. So an A goes here, right? So this is radius. Now what's the next step? Oh, I'm going to do a diameter. And what am I going to call it? Okay, and so this would be B, this would be D. And then what am I going to do? A secant. What's a secant? Secant just intersects the circle at two places, right? That's the definition. I was supposed to make an arrow. It's not making my arrow. Okay, and what am I supposed to label the secant as? Um, so E, F, and then what else do I have to make? A tangent. And a tangent only touches the circle once, right? So here's my point, and then I'm going to try and draw it that it only, oop, oop, there, something like that. Okay, makes sense? And yours could look different than mine. This is on your test, though. I even told Miss Shana that this morning. I don't do surprises on my test. If someone doesn't know what's going to be on the test, they just haven't been here, right? Because I pretty much tell you because I find that's fair. If I'm going to test you on it, you should know what I'm testing you on. Yes. Mm-hmm. What? Oh, what was this supposed to be labeled? D what? Oh, GH. Okay, I didn't label that last one, so let me go ahead. It doesn't matter where you label your segment as long as it's labeled. Okay? Because as long as you have points there that are labeled. Any questions on that one? You understand it? Yay! That's my goal. Okay, now we talked about different theorems of these. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. So I'm thinking it wants this length right here. If you ever are confused, just raise your hand. I'll let you know. Because I agree with you. It's not, yeah. If you ever need me to say which segment are they talking about, just raise your hand. I'll come over there and tell you. So they're talking about that segment. What do you know about all radii of a circle? They're the same. So this is a radius, and this is 12.4. This is a radius, so that's 12.4. And guess what? This whole thing is a radius, right? So this whole length should equal what? 12.4. So if I take 12.4 and I subtract 6.6, that will give me this leftover piece here. which is what? 5.8? Now, you could have done this a different way. You could have used Pythagorean theorem. That would have been a lot harder, but you could do it, and you still should get 5.8 if drawn accurately. Does that make sense? Yes, no? Because this is 10.9, so this would be 10.9. And then you have a right triangle. You could have used Pythagorean theorem. I could have done x squared plus 10.9 squared has to equal 12.4 squared, right? And then you just subtract those squares and take the square root. Did we get the same answer? It should be. Let's double check and see if CUDA does all its math correctly. So 12.4 squared minus 10.9 squared. And hold on a minute, we'll talk about that in a second. Yeah, I mean, we're off a little bit, but it should have been about the same. They probably did some rounding when they were doing this, so there was probably some rounding errors. But yeah, 5.9, 5.8. Um, they're on different sides of the equation, Lakeisha. So when you found the squares, you'd have to subtract to get x squared equaling, what was that, 38 point something, and then take the square root. Yeah, they got about 5.9. I'm going to guess there was rounding errors with these, that this was actually supposed to be a little bit, yeah. Okay, but you could have done that one two ways. If anybody ever tells you there's one way to do a math problem, they just lied to you. There's many different ways usually to do problems. Okay, these are my favorite just because they're like a puzzle. Does anybody else like these? You like those? Okay, so if it turns out that we had another theorem that if you have a point outside the circle and you have tangent lines drawn, that from this point to where it meets the circle has to be the exact same length. So if here to here is 12, here to here is also 12. What that allows us to do is because we have a missing piece here. So we're going to walk around this shape to find this piece right here. This one. This is the one that's missing, right? So what is 19.6 minus 12? 7.6. And if this is 7.6, then guess what? This is 7.6 on the other side. So what's 19.4 minus 7.6? 11.8. And so then this would be 11.8. And it asks for a perimeter. So you have to add this one, and this one, and this one, and this one. Just all the outside. And that would give you your perimeter. So it'd be like 12. I'm just putting 0.0 so I can line my decimals up. 0.6, 19.4, 11.8, and add them all together. 62.8, and it didn't give a unit, so I'm just going to put a unit. Yay or nay? Okay. So it says here, find the length indicated around your. This one I'm forced to find the missing length by doing Pythagorean theorem because I didn't get this piece over here. I don't know what this is, right? So, but I have a right triangle with a missing side length. So this one I have to use Pythagorean theorem. So this would be x squared plus 8.1 squared will equal your hypotenuse squared. Your hypotenuse is always across from the 90 and your longest side. So 20 squared. So x squared plus, what's 8.1 times 8.1? Has to equal 400. And then you just subtract these and then take the square root. What is 400 minus 65.61? What is it? 334.39, and then take the square root of this, and that will give you your answer. So what's the square root? 181, which would be about a 2 then. And I don't have a unit, so I'm just going to put a U for units. Okay? Questions? And then this was, I think this was the ones we were doing yesterday, right? Okay, so here it says, find the measure of angle F G G E right here. F G E. Well, if this is 57 degrees here, that means your central angle is 57 degrees. Does everybody agree with that statement? Well, aren't these vertical angles? Yep. And it says here, assume that lines are diameters, appear to be diameters, are actually diameters. So we can assume then those are going to be vertical angles because they said both of those are diameters. And so then, huh? You can have infinite amount of diameters. So this is 57 degrees right there. However, I need ED, right? Oh, that's it. Okay. That was easy. Now, you could have done it differently. How could I have done this differently? If I didn't want to use, if I didn't want to use vertical angles. Okay, so I could find ED is what you're saying? Okay, so I could take, because this is a diameter, I know that this side has to be 180. So I could do 57 plus 78 is what? And then I could subtract that from 180. So this piece here is 45 degrees, right? Oh, because then you have this diameter here, right? Do you see this piece here? Then you could just add these two together and subtract it from 180. So 78 plus 45 is what? And then subtract that from 180. Ah, see how math is beautiful? I could do it different ways and get the same answer. Either way would have gave me 57. You could have noticed your vertical angles, or you would have had to split it up into looking at the two diameters. As long as you get 57 degrees, you're in good shape. Okay, what about number 11? I need H, I, HIF is this angle here. Well, kind of the same way. I know this side has to equal 180, right? Because of this diameter here. This is a diameter. So these two added together has to equal 180. So this would have to be 50 degrees because 130 plus 50 is 180. Did I lose anybody? Okay. Now I just add these two arcs together and that would be the same because this is a central angle. So if I add these two together, it's going to give me this whole central angle here. So 50 plus 59 is 109. So this would be 109 right here, degrees. So you had to find this missing piece and then add those two together to get that whole angle. And central angles and the arcs they intercept, or subtend, or I use cut, are the same measure. So central and this should be the same. Inscribed are different. Those are always half the arc it subtends. Which, any questions on number 11 before I move on? Y'all are geniuses. We have that. Okay, over here, it's asking find the measure of the arc or angle indicated. And I do have a diameter. Here's a diameter, right? So this side is 180. What's this arc measure over here? Do I know? Can I figure that part out? Here's this. So you have to double this because it's an inscribed angle now. What's 42 times 2? Is 84. So arc FG, capital G, I was going to write a lowercase one, has to be 84 degrees. So this is 84. Does that help us at all to find this angle here? What's this arc over here going to be? These two have to add up to what? 180. So 180 minus 84 is going to give us arc FE, which is equal to 96 degrees. Well, now, would be a good color. Now we have the subtended arc of this angle that I'm looking for, or the angle that it cuts. If I divide this by 2, that's this angle over here. What is 96 divided by 2? So our answer is 48 degrees. Our X, or question mark, is equal to 48 degrees. Yeah, this is where we're using your deductive reasoning skills. It's like a puzzle. So if I'm looking here, I can find this angle measure, right? Because this is where it subtends or cuts the angle. What's 95 times 2? Is it 190 degrees? Now that'd be this whole thing here. Is it a arc? Yeah, CD. Is that a B that I went over? Does that help us? How does that help us? So, what did you say? You say you did it.
This one I did. I got.
Mm-hmm.
I got this one. And then
Yep. So let me go ahead and. So Howe said then that if you looked at this side over here, right, that that this arc is also 190. So if so this one would have to be 80, is what you're saying, because over here this missing piece was 80. So this would have to be 80. Because there was like an overlap. Okay. So yeah, because there was like an overlap. Okay, so you have the purple, right? Which is this one. And that's 190. But then when I have this one over here, this one's 190 also. So this would have to be 80. Okay, this 190, I'm just going to call this x here, okay? Is equal to x plus 80, right? And then this one over here is also 190, right? Which is x plus question mark. Well, it has to be 80 because you have the two x's that are exactly the same here. This piece right here is the same for both. That'd be the x. And x plus 80 has to be 190. So this other piece would have to be 80 for it to add up to 190. Because this piece right here is going to be the same no matter what. This is going to have to be 110. Because there's an overlap. Okay. Just take a minute to process it, and it'll make sense. Okay. Now we're going to 80. It's because it. Let me come up here and see if I can explain that a little bit better. From here has to be 190 because 95 times 2 is 190, right? Okay. Well, if that's the case, then this arc has to be 110, right? Because 190 minus 80 is 110. I also has to be 190 because this says 95. 95 times 2 is right here. That has to be 190 because you have to double the 95. Well, if this is 110, what's 190 minus 110? 80. That's why that other side's 80. From here to here is 110. The whole thing has to be 190. What's 190 minus 110? Got it? This piece was the same for both of these arcs, from here to here, and then from here to here. That's the same. So if this had to be 190, and then this had to be 190, then these two would have to be the same.
can you just look at it and say that? I mean, without.
How did?
It's just if both those angles are 95, that side's 80, that side's 90, right?
Correct. Or Or you could have done the math and just found this to be 110 and then take 110 away from 190. Either way would work. But some people can just look at it and see it. Other people have to actually work out the math. Either way. Some people, that's the one thing about geometry. People who are visual, like the artists in the room, they tend to like geometry a bit more because they can see it and they have a better intuition about all of those concepts and how it's all related. Okay, so while I'm up. Yeah, and then after the test, you can start your questions. Or study and do the review for final if you want to do the objective test. I'll have to grade. I'm just teasing you.
My 12-year-old said he'd rather take the exam. If he got to use all his notes, he'd rather take.
I just like to tease you, Troy. Is that okay? I like to tease you. Is that okay? Because it's not a mean thing. Okay, so I gotta pull up my. Okay, I'm gonna start. Okay. To the left. Okay, today we're going to learn how to define angles formed by secants, tangents, and tangents of circles. We're going to use theorems about the measures of the arcs intercepted by these angles. Okay, so we have case one, where the vertex, and when we're talking about a vertex, you're talking about, do you see here how this creates an angle? Right here. Oh, I don't have it in Cami. Oh, I did not do this right. Sorry. Okay, let me make this bigger. Okay, so this vertex right here, do you see the vertex? And it's talking about this angle where these two lines intersect. So we have a secant intersecting a tangent, and that vertex where they cross, that intersection of those two lines, is on the circle. We also have two secants that intersect, and their intersection is also on the circle. You see that? Okay. Now I have two secants, or it could be two chords. Where if I had a circle and I had two chords intersecting like this, boy, that's an ugly circle. But this one, the vertex where they intersect, would be inside the circle, right? Okay, good. We know our location pronouns. On, in. And then this one's out. These two, the intersection is outside the circle. Where the vertex is tells you which formula you're going to use. Okay? So, let's talk about the formulas. When the vertex is on the circle, that just means it's kind of like an inscribed angle, that this angle here is half of the arc measure. So, this arc that's in between here, that arc right there. So, half of this arc is this angle measure. Or if I have the angle measure, I double it to get the arc. So let me change this color for a minute so you can see it better. So this one is talking about this arc here, right? So what would be angle, the measure of angle BCD? You would say it's 1/2 of 142. Or you just divide it by 2. So what's 1/2 of 42? 142. 71. So this would be 71 degrees. Now they're talking about a different one. Sorry. So now you have the bigger one here. They're talking about this angle, this arc, but they gave you an angle measure. There's no number, but what does a box stand for? 90. And if I take 90 and double it, that will give you arc A, B, C. So what's arc A, B, C? When I take 90 and times it by 2. That's 180. So AC actually has to be a diameter because it's cutting the circle in half. So these are very similar to inscribed angles and the central angles when it's not. The inscribed angles and the arc of intersects. It's just half. Are we good on that, or do I have to explain that better? You good? Okay, now, vertex is on the inside of the circle. Inside. So, to find angle 1, and angle 1 and this other angle here are vertical angles, so those will end up being equal. This would be like whatever angle 1 is, this one's going to also be that measure. Because vertical angles, anytime you have straight lines that intersect, these are vertical angles. Okay, so you would say that this arc and then this arc over here, you would add them together and then divide by 2. And that would give you here and here. Oop. Any questions on that part? Let me go ahead and give an example. So here they're saying, and they want angle SQR, where SQR is this angle right here. So the two arcs on either side, you add those together, and then you're going to divide by 2. So 100 plus 32 divided by 2. What's 100 plus 32? 132 divided by 2 is equal to what? 66? So this would be 66 degrees, and also on the vertical angle on the other side would be 66 degrees. Because it's not on the circle, it's inside and it's not at the center. Let me erase this so that way you could see what I'm talking about, because I drew all over it. Okay, is Q the center of the circle? No. So it's not the center, so it can't be 100. Is Q on the circle to make it an inscribed angle? No. So it's not an inscribed angle either. Okay? This this angle right here. And then of course, this one also is 66 degrees because of vertical angles. They didn't ask you this one, but I'm telling you that both of those would be the same because they're vertical angles, which we learned, I think, like the first week or second week of school. Okay, vertex is on the outside of the circle. In this case, you are going to take AD and subtract BD and then divide it by 2. So it's a different formula. So let's go ahead and look at an example. So over here, I would do 174 minus 98, and then I would divide this answer by 2. What's 174 minus 98? And then you divide by 2, and that will give you your answer. So this angle here is 38 degrees. Oh no, I only have one number. I only have EG. How am I going to be able to do this problem? What do you know about a whole circle? It has to be 360. So EHG is going to be 360 minus 132. What's 360 minus 132? 228. So this over here is 228. Now you can go ahead and figure this out because now I have the two numbers. So it would be 228 minus 132 divided by 2. Which is what? 48. So then this angle here, angle EFG, is 48 degrees. It's right, talking about this one right here. If these were too small for you to see, I did try to get the summary bigger with examples on there. Do you see that on the bottom? Hopefully you're able to see those a little bit better. Where they gave you examples and then they gave you the 3 on a circle, inside, and then outside. Right? And they did the math for you there. Let's try to figure, oh, why is this locked? Add more pages. Oh, look at that. now they're making me, because remember I was on a trial. I guess you're only allowed a couple pages, and to get the whole thing, they're gonna make me pay for it. Yeah. I know. Oh, wait a minute. Do they not have the examples? This one doesn't have the examples. Okay, let me grab one of these sheets. There must be. Hold on. It wasn't them. It was me. I wonder if I didn't open up the right one. Oh, give me a second. Go ahead and see if you can apply it to the first example while I'm pulling this up. Oh, that's not what I wanted. Oh, jeez. There we go. And now I have them. I don't know why that other one didn't have examples. Okay. Use your phone for now. Okay, so number one, first of all, is this is this inside? Is the vertex inside, outside, or on the circle? Outside. So this is the one where you use the formula. Angle E is going to equal 1/2 of 133 minus 65, correct? Okay, so what's 133 minus 65? 68, and then we do what? Divide by 2. So angle E is 34 degrees. And now we're on the inside of the circle. What's the formula we use then? It's 1/2 and you add, right? So I'm going to, which one are they? They're wanting angle R or TRS. So angle TRS is going to equal 1/2 123 plus 67. So 123 plus 67 is what? And then we're going to divide this by 2, which is equal to 95 degrees. Okay, this one's on the circle. So basically, this is an inscribed angle here, right? So what do I do with this 210 to figure this out? 210 divided by 2 is equal to 105 degrees. Must be 105.
Oof, not the spiciest stuff.
Spicy.
Too much spicy to be heartburn.
Oh, paper fell.
Is that a coffee mug warmer?
Over here, yeah.
Ooh, Amazon.
Mm-hmm.
I need to find me one of them. I drink coffee all the time, and I hate when you gotta rewarm it.
Doesn't taste the same.
Mm-mm. Like the microwave nuke it all the way.
Okay, so can I go to the next one? So these are a little spicier, and they're spicier because you may have to do a little bit more algebra. You may have these on the test.
Oh, God.
Okay, in this case, oop,
A bonus.
no, these won't be bonus. In this case, what did I do with the extras? Oh, here. I was given the answer, right? It's on the inside, but they gave me the answer. So 105 has to equal 1/2, and I'm going to use this as an x, and I think we add, right? X plus 65. So what would I do first to get rid of this 1/2? Yes, if you multiply by 2 on both sides, then that 1/2 cancels out. Here, what's 2 times 105? 210. Has to equal x plus 65. And now you would just do what? You subtract. So what's 210 minus 65? So that x, this outside arc, is equal to 145 degrees. So for this one, they gave you the inside angle. You had to substitute it in. And then you're just working the formula out backwards. You're solving for x. This is the same case. When it's outside, instead of an addition, what do I have? Subtraction. So in this case, I know that 45 degrees has to equal 1/2 times x minus 61. So what do I do on both sides to get rid of the half? Multiply by 2. And then you get 90 is equal to this half and this 2 cancels. So you're just left with the x minus 61 here. And so now what am I going to do to both sides?
Add 61.
Add 61. Add 61. So x is equal to 151 degrees. Number 6 is a little trickier. I'm going to call this x. So what would I call this all the way around this outside here? If from here to here is x, go away. From here to here is x, then this outside piece is 360 minus x. This is still on the outside of the circle, so you're still going to use the same formula. So 55 degrees has to equal 1/2 times x. No, sorry. 360 minus x minus x. Before I multiply by 2 on both sides, I'm going to combine my like terms. What's a negative x minus x? Negative 2x. 360 minus 2x. And this you have your 1/2. And this you have your 55. Now what do I do to both sides? Multiply by 2 to get rid of the half. So you get 110 is equal to 360 minus 2x. Now what do I do? Yep, subtract 360. And I get a negative 250, right? Is equal to a negative 2x. So then what am I going to do to solve? Divide by negative 2. And so what does x equal? 125. So right here, this would be 125. Go ahead and take your 15-minute break a little early. And I will give you your paper.